Alright, the last one of continuity, the intermediate value theorem. Okay, I'll let you read through this, but basically what it's saying is that if you've got some graph of a function that is continuous, so it doesn't have any holes and doesn't have any asymptotes or anything like that, on a given interval, okay, on a given interval, it doesn't have to be on it forever, but like this one is just from A to B, so this interval from A to B. So it may not be continuous over here or over here, but that doesn't matter, we only care in between these two values. And then there is some other value, some height, that's in between the function's height at A and the function's height at B. So you'd have some value k that is in between f of A and f of B. And it could be the other way around. It could be like this. That's okay as well. It just has to be in between those. Then that means there has to be some value c that if you plugged into the function it would give you k. There's got to be some x value that you could plug in that would give you k. That's all. So it seems kind of obvious. Yeah, of course there's got to be an x function or an x value that you could plug into the function, but that's all this theorem is saying. And so we're going to use this idea to narrow in on some points. I'll show you one way we can use it here on the next page. So it says, use the intermediate value theorem to show that f of x has a 0 in the interval 0 to 1. So let's just first start off with a couple things. If f of s is continuous on the closed interval a to b, well here my interval is 0 to 1, right? So if I said a to b, well here it's actually 0 to 1. They give me the interval. And k is any number between f of a and f of b. So what is k in this situation? Well, it's a 0. So here k equals 0. So to figure out if k is between f of a and f of b, we're going to have to figure out what is f of 0 and f of 1. So let's go ahead and do that. Let's find f of 0 first. And that would be 0 squared plus 2 times 0 minus 1. Well, that's easy. F of 0 equals negative 1. Let's find f of b, which is f of 1 as well. I'll do it in blue. So f of 1 would be 1 squared plus 2 times 1 minus 1. These guys just kind of cancel each other out. So we got that f of 1 is 2. All right, so this is like my f of a, this is like my f of b, and all we're really asking, just like we were before, we're saying is f of 0, which is negative 1, is that between, or is k, I'm sorry, between that value and f of b, which is f of 1, which equals 2, is that value in between? And yeah, it is, right? We know that it is, because k is 0. I forgot to put that k equals 0. And yeah, 0 is between negative 1 and 2. So the intermediate value theorem applies here. We do have a k value that is between our f of a and our f of b, right? So remember, that's all we're trying to find out. And it has to be continuous. Well, this is just a parabola, and we know that parabolas are continuous. So all the parameters or all the requirements for intermediate value theorem apply, and so we could say, therefore, there must be some value f of c which would equal 0, which we are calling k. That's it. We're not even asking to find the 0, right? It just says use the intermediate value theorem to show that f of x has a 0. And so we found f of a, we found f of b. We said that 0 is between my f of a and my f of b, therefore there has to be some value c, which when I plug it into the function would give me 0. That's really all there is to it. All right, let's go to the next page. Okay, so this one is the exact same question, and I don't know why I did that. So we're actually going to skip this, but I want you to take a look at this problem and I'm going to give you straight off a con. So maybe just copy this problem down on the next paper. Yeah, so take a look at this. Maybe you might want to pause the video, take a moment to copy this down. All right, and let's talk about it. It says, let g be a continuous function on the closed interval negative 2 to 4. So we have some interval negative 2 to 4, and they're telling us it's continuous that whole time. So it's continuous from -2 to 4. All right, good. And they went ahead and gave us a g of x value. So we have g of -2, g of 0, g of 2, and g of 4. Right? So we got all these values. So the question is, which intervals must contain a solution to g of x equaling -1? So when do we know for certain that this g of x equals -1? So is it in between -2 to 0, from 0 to 2, or from 2 to 4? And it says select all that apply, so multiple ones could be the answer, or it could be none of them. So let's just kind of think about this. What we could do is just kind of put this -1 here, put it here, and put it here. And we're going to look at this one at a time. First, let's look at this one. Is -1, which is like my k value, right? Remember, that's what this is. That's what my k value, that's the height function that I'm trying to find if it ever equals that. Is -1 between 1 and -2? And it is, right? Don't we know for certain that -1 is less than 1, and it's also greater than -2? So yeah, it is. So there has to be some x value that I could plug into this function in between -2 and 0 that would give me -1. So I can check off that -2 to 0 is definitely a solution. Okay, let's look at the next set here. Let's look at from 0 to 2. Is -1 in between -2 and 3? Maybe I could kind of like box this up a little bit so you can kind of see that we're just really doing like 3 problems in one here. Okay, so now I'm looking at this blue interval. Well, yeah, we know for certain that -1 is between -2 and 3, right? -1 is greater than -2 and less than 3. So that means there must be some x value between 0 to 2 that we would plug into the function g of x and get -1. So that means that there is some solution in between 0 and 2 as well. All right, let's look at the last set here. We got between 3 and -5. Is -1 between those two values? And again, it is, right? -1 is greater than -5, and it's less than 3. And so, again, because -1 is between these two values, it's between, you could say, f of a and f of b. That means there's some value c that's between a and b that if we plugged into this function would give us -1. That's all that we're really asking here. We're not even asking for the solution. They're just asking, is there a solution in this interval? And there is. There has to be, because -1 is between 3 and -5. Therefore, the x value that we plugged into this function to get -1 has to be between 2 and 4. That's it. So all 3 of those apply, and that one actually requires that you would click all 3 of those to get it correct. Okay, I know it's a little bit weird concept. It seems almost too easy to be true, that's all you're asking, but that's really all there is to this. So we'll talk more about it in class, but until then, I'll see you guys in the next video.